Hello, my friends. IBM is here to bring you another episode of Learning Physics, and today I'm bringing a part 5 of Physical Quantities, AS Physical Quantities, Units and Measurement Techniques. In part 4, I think we stopped on page 40, and in part 5, I want us to start from page 41. Without wasting time, I want us to go to the document and start solving. Which pair contains one vector and one scalar? We look for one vector and one scalar. Displacement is a vector, acceleration is a vector. That one doesn't work. Force is a vector, kinetic energy is a scalar. We want one vector and one scalar. Momentum is a vector and velocity is a vector, so that is out. Power is a scalar, speed is a scalar, so our answer is going to be B. When a constant braking force is applied to a vehicle moving at a speed v, the distance d moved by the vehicle in coming to rest is given by the expression d equals to kv squared, where k is a constant. When d is measured in meters and v is measured in meters per second, the constant has a value of k1. So d therefore is going to be equal to k1 times v squared. So this is v squared, but is in meters per second. What is the value of the constant when the distance is measured in meters and the speed is measured in kilometers per hour? So d is going to remain in meters, but the speed is going to be measured in kilometers per hour. So let's first convert 1 meter per second to kilometers per hour. So we convert 1 meter per second into kilometers per hour. So 1 meter is going to be, of course, 1 over 1000 in kilometers. And 1 second is, of course, going to be 1 over 3600 in hours. That means 1 meter per second is going to be 1 over 1000 kilometers divided by 1 over 3600, which becomes 3600 divided by 1000. So the answer here is in kilometers per hour. So it means 1 meter per second is going to be 3.6 kilometers per hour. So if 1 meter per second is 3.6 kilometers per hour, then v in meters per second will be 3.6 times v in kilometers per hour. So v meters per second should be equal to 3.6 times v in kilometers per hour. Okay, so we want to find a new constant here. So the d should therefore be equal to a new constant, k2. Where there is a v, I'll therefore put there 3.6 v, and this is still squared. Now I want the constant k2. Remember, d was k1 times v squared, so I will say where there is d, I'll put k1 times v squared. So this is k1 times v squared is equal to k2 times 3.6 squared times v squared. So v squared has cancelled out. So it means the constant k2 which I want to find is going to be k1 divided by 3.6 squared. So I'll just press my calculator. Where is the calculator? Okay, let me find the calculator. Okay, so I have 1 divided by 3.6 squared, which gives me a 0.0772 times k1. So this is 0.0772 times k1. So that means my answer is going to be strictly A. Okay, the angular deflection of the needle of an ammeter varies with the current in the ammeter as shown in the figure here. Which diagram could represent the appearance of the scale on this meter? Now when you see the actual current, as the actual current increases, the angular displacement reaches a point where the change in the angular displacement becomes very small. So the change in the angular displacement, the angular deflection should become very small. It goes on decreasing. Now it means we cross out B because the B is showing that the change in the deflection goes on increasing as the current increases. So D is wrong. Then D is also wrong because it shows initially there is an increase. It is showing an increase then a decrease, yet we see that is only a decrease right from the start. The gradient goes on decreasing. So D is also wrong. C is also going to be wrong because C shows a decrease and then an increase, yet it is just a decrease in the gradient. The change in the angular deflection goes on decreasing. So C is also wrong. So our answer is going to be A because A is showing a decrease in the change in the angular deflection as the current increases. So the interval between this division goes on decreasing because as the current increases, the gradient is decreasing. That means the change in the vertical axis or the change in the angular deflection becomes smaller as the current increases. So the answer is going to be A. What is a reasonable estimate of the average gravitational force acting on a fully grown woman standing on the earth? So when we talk about gravitational force, that is the weight, and we know that the weight is equal to m times g. So a fully grown woman, if she is not very fat, we can say her mass is approximately 80 kilograms or 70 kilograms. So this would be 80 times g is 9.81. So 80 times 9.81, this is approximately 784.8 newtons. So which answer would make more sense here? So it means this is wrong, this is out, this is out. It is most likely going to be 650 because if I was to take a mass of maybe 70 or 60 kilograms, I would come to 650. Alternatively, you can prove backwards by finding the mass of a fully grown person. For example, if the weight is, if I say, okay, let's say the weight is 360, 350. This should be equal to the mass times g, which is 9.81. What is that mass? So 350 divided by 9.81 gives us a mass of 35 kilograms. A fully grown woman cannot be a mass of 35 kilograms. Therefore, this makes C wrong. But we can check 650 by using the same approach. So it's a 650 divided by g, which is 9.81, should give us the mass. Let's see what mass we are most likely going to obtain for a fully grown woman. So this is 650 divided by 9.81, which gives us 66 or approximately 70. So this gives us a mass of 70 or approximately 70 kilograms. So this can be a mass of a fully grown up woman. Which definition is correct and uses only quantities rather than units? That means only quantities but not units, or only quantities without units. Density is a mass per cubic meter. Cubic meter, those are units, so that is out. Potential difference is energy per unit current. V is actually energy per unit charge, not per unit current, so this is out. Then pressure is force per unit area. I think this is correct. Pressure is force over area, so the answer is equal to C. That is the force acting normally per unit area. Speed is distance traveled per second. Per second is units, so this one is out. The average kinetic energy E of a gas molecule is given by the equation E is equal to 3 over 2 kT, where T is the absolute Kelvin temperature. What are the SI base units of K? I think we have answered a similar question, but we can still do that. So one, we make K the subject. So K is going to be 2 over 3 times E divided by T. We know the base units of T is Kelvin, capital K. We know the base units of energy at this time. Energy is work done, and work done can be force times distance. So the units are kilogram, meter squared per second squared for energy. So we are now having the units of K as those of energy, which are kilogram, meter squared per second squared divided by T, which is per Kelvin. So this will be per Kelvin. So these two are automatically wrong. This one is also going to be wrong, and our corrective value is going to be D. An analog meter has a pointer which moves. It has a pointer which moves over a scale. Following prolonged use, the pointer does not return fully to zero when the current is turned off. When the current is turned off, the pointer does not go back to 0 when the current is turned off. So it means this one is wrong because this one is showing the pointer goes back to 0 when the current is turned off. This one is showing, although it is showing that there is a current when there is no deflection, which doesn't make any sense. Even this one is showing there is a current when the scale deflection, when there is no scale deflection. But they say the pointer does not return fully to 0 when the current is turned off. That means when the current is turned off, the pointer will go back to a certain value on the which is actually going to be the y-intercept. So our values should start with the y. They should have a y-intercept. But they said, and the meter has become less sensitive at a higher currents. That means it becomes less sensitive at higher currents. That is, if the current increases, the change in the scale reading must be very small because the meter becomes less sensitive. D is going to be wrong because this is showing that as the current increases, the meter becomes more sensitive. In other words, the gradient is becoming steeper, which means the meter is becoming more sensitive to high currents. So the answer is going to be C because we see that the gradient is decreasing, which means the meter is becoming less sensitive to higher values of current. So our answer is going to be C rather than D, rather than A, rather than B. The arrow represents the vector R. Which diagram does not represent R as two perpendicular components? Which diagram does not represent R as two perpendicular components? So this is vector R. If I was to draw, if I try to look at the components of R, most likely they should be similar to these ones here. So when I resolve R in the horizontal, I could have a component in the horizontal, I could have a component in the vertical, which qualifies A to be correct. Then B could also be correct because if the vertical component becomes smaller, then which diagram does not represent R as the perpendicular, as two perpendicular components? So we have just twisted this angle here. So if R was to be here, then it could be twisted in such a way that it could give us a horizontal component and a very small vertical component. Because the angle between this one here and the horizontal has been increased, then we can rotate this one further upwards. So that means that one can represent R as two perpendicular components, just rotating anti-clockwise. Then if we check C, we can check C by trying to find the resultant of these two if it can be R. If you have a ruler, you can try to complete this using a parallelogram rule and see if this gives us R. If these are the two components, if those are the two components, notice that R, this will not give us R because look at how R is the orientation of R. So this means this is going to be out. We can also check this one. You can transfer this vector here to the other one using a set squares and a ruler. You can transfer that one to that one. You transfer this vector to the other hand so that you complete the parallelogram, and you notice that R will be somewhere there. And you notice that this one may also represent R. So this one, if you were very careful, you translate these vectors, you notice that this one will also be a representation. So our answer is going to be C. Why? Because if we try to complete these diagrams by measuring using a ruler, this can be R. You can also try this one if you want, and you see if this can't be R. You can try this one, but when I try this one, you notice that it points below the horizontal, so this one cannot represent R. Therefore, our answer is C because they said which diagram does not. So the answer is going to be C. Which statement includes a correct unit? Energy, Newton seconds. Energy, work done, which is force, times distance. force is newtons, distance is in meters, Newton seconds is a unit of momentum, so this is out. This one is also out. Newton seconds is a unit of momentum. It is force times time. Momentum, Newton seconds, I think this is correct. Which statement includes a correct unit? So momentum, Newton seconds, I think that is correct. Torque is force times perpendicular distance. Torque would be Newton meters, not Newton seconds. What is the joule? The joule in SI base units. Joule is a unit of energy, and at this time we know that energy is kilogram meter squared per second squared. A joule is work done, a unit of work done, which work done is force times distance. Force can be kilogram meters per second squared because it is mass times acceleration. Distance meters, so this gives us kilogram meters squared per second squared. A student is given a reel of wire of diameter less than 0.2 millimeters. So if the diameter is less than 0.2 millimeters, of course the instrument we can use here is a micrometer screw gauge for diameter. And is asked to find the density of the metal. Remember, to find the density we need the mass over volume, but volume is going to be volume of the sphere is going to be pi d squared over 4 then times the cross-sectional area, or pi r squared over times the area times cross-sectional area times a certain length, or times the height. So this is pi d squared over 4 times the height. That will be the volume. So which pair of instruments would be most suitable for measuring the volume? So volume is pi d squared over 4 times h, where h is going to be a height or a length. I'll just say times length of the wire. So diameter micrometer screw gauge, because it's less than 0.2, and the length can be measured using a meter rule. So our answer is going to be B. We can't use vernier caliper for such a small length. The most precise instrument would be micrometer screw gauge for such a small length. What is the unit of weight in terms of SI base units? So weight is the Newton, but this is not SI. The Newton is a unit of force, which is mass, kilogram, acceleration, meters per second squared. So our answer is automatically B, but it is not C. At temperatures close to 0 Kelvin, the specific capacity of C of a particular solid is given by C is equal to B, T power 3, where T is the thermodynamic temperature and B is a constant characteristic of the solid. The SI unit of specific capacity is joule per kilogram per Kelvin. What is the unit of constant B? So I will make a B the subject then. So B is going to be C divided by T power 3. C is the specific heat capacity whose units are given as joules per kilogram per Kelvin. And T is temperature whose unit is Kelvin. So first of all, I can change the joule. The joule is the same as units of energy, which is kilogram meters squared per second squared. So the units here will be kilogram meters squared per second squared divided by that is the joule alone, then times per kilogram, then times per Kelvin. I just brought the other units, so per kilogram cancels out. Then T cubed, that would be K power 3. When we simplify this, we remain with the meters squared S power negative 2, Kelvin power negative 1 divided by Kelvin power 3. We subtract the powers, so it becomes Kelvin power negative 4. It is negative 1 minus 3, which becomes negative 4. So this means our answer becomes B. In making reasonable estimates of physical quantities, which statement is not correct? Number 1, the frequency of sound can be of the order gigahertz. The frequency of sound can be of the order gigahertz. Okay? Giga means 10 power Giga means 10 power 9 hertz. Remember, sound travels at a speed of around 330 meters per second. We can easily, of course, sound undergoes diffraction because it has a longer wavelength. So if sound has a longer wavelength, then its frequency cannot be that big, because frequency is inversely proportional to wavelength. So since sound has a longer wavelength, its wavelength is greater than the wavelength of sound is greater than that of light. That means the frequency of sound should be much less than the frequency of light. And 10 power 9 hertz is a frequency in the region of electromagnetic waves. So it means it could be a frequency of one of the electromagnetic waves. So that means this one is not a reasonable estimate. The wavelength of light can be of the order, that one is fine, 600 nanometers, that is fine. The Young modulus can be of the order 10 power 11, that is also common. You have seen Young modulus expressed as 10 power 11 pascals. Beta particles are associated with one unit of negative charge. Beta particles are associated with one unit of negative charge. That is also very true. Beta particles can have a unit of negative charge. Which list shows increasing lengths from beginning to end? I think if you're an expert, you'll notice that the answer is going to be C, because nano is 10 power negative 9, micro is 10 power negative 6, mid is 10 power negative 3, cent is 10 power negative 2. So it means cent is the biggest. We want increasing length, so this one is not true. This one is not true. Cent is the biggest, and millimeter is bigger than nanometer, so this is wrong. So our answer is C. Which equation contains only scalars? Here they are vectors, so that is out. Here they are only scalars. Work, time, power, those are only scalars, so the answer is going to be B. Pressure is a scalar, but force is a vector. Area is a scalar. Velocity is a vector. Displacement is a vector. Time is a scalar. So our answer is going to be B. The time t taken for a satellite to orbit the Earth on a circular path is given by that equation. Where r is the radius of the orbit, m is the mass of the Earth, and k is a constant. What are the SI base units of k? So I make k the subject. K is equal to t squared m divided by r cubed. What are the SI base units of k? What are the SI base units of k? So I'll just substitute. T is time. So the units here will be T is time, which is S squared. Capital M is mass, which is going to be kilograms. R is radius, which is meters cubed. So answer will be kilogram second squared per meter cubed. So this one is wrong. Per kilogram is out. And so it is kilogram S squared per meters cubed. So our answer is going to be C. Kilogram S squared, m goes up, it becomes m power negative 3. So this is also out. Which law gives reasonable estimates for the mass and the speed of an adult running? Of course, the mass of an adult, this is 600 kilograms, that is too much. So we cross out, this one is 6 times 10 power 0, which is 6. So we have B and C, that is 60 kilograms. Then let's check the speed. B is showing 5, this is 5 meters per second, and this is 50 meters per second. So this one is too much for a person, an adult running. So this is because even the fastest runner could be running at around 10 meters per second. So this one is too much. So our answer is going to be B. What is the unit of the Young modulus when expressed in SI base units? So Young modulus, of course, Young modulus is stress over strain, stress divided by strain. Stress is force over area, strain is extension of original length. So when I divide, I get the reciprocal, so it becomes original length over extension. So here there is no unit. We will remain with the unit of force, which is kilogram meters per second squared divided by meters squared. So this becomes kilogram meters divided by meters squared becomes meters power -1, then s power -2. So this makes our answer to be precisely kilogram per meter per second squared, which is A. The Reynolds number is a constant used in the study of liquids flowing through pipes. Those who have studied fluid mechanics, you might have seen the Reynolds number. R is a pure number with no unit. Rho is the density. So if rho is the density, then the unit here is kilogram per meters cubed. V is the speed, that is meters per second. D is diameter, that is meters. What is the SI base units of mu? So I make mu the subject. So making mu the subject here, mu is going to be equal to rho V D divided by R. Remember, R has no units. So rho is kilogram per meters cubed times V, which is meters per second, times meters. So the units will be kilogram meters times meters power -3 times meters. I think that is meters power -1, then s power -1. In multiplication, we add the powers. So it becomes kilogram per meter per second. So our answer is going to be D. When a force F moves its point of application through a displacement S in the direction of the force, the work done by the force is given by work done is force times displacement. How many vectors and scalar quantities does this equation have? So we have F and S, those are two vectors, and work, that is one scalar. So we have one scalar and two vectors. So one scalar, which is the work, and two vectors, which is force and displacement. The density of the material of a coil of thin wire is to be found. Thin wire. Which set of instruments could be used to do this most accurately? So to find density, we need mass over volume. So we need a balance. We need a balance to be able to find the mass, because we want to find the density. So we need a balance by all means. So spring balance, band balance. Here, Newton meter. Newton meter can also represent a balance. Tape measure, lever balance. Okay. So we also need the volume. So to find the volume, we shall need pi diameter squared over 4. That is the cross-sectional area times the length of the wire. So to find the length, we shall need a meter rule. To measure the length, we shall need a meter rule. Okay. So it means I have eliminated this because there is no instrument to measure the length of the wire. So I've eliminated this one as stopwatch, Newton meter. We don't need a stopwatch anyway. There is nothing to measure L. Here, tape measure, vernier calipers, lever balance. A vernier caliper will not be good to measure the diameter of the wire. So vernier caliper is also out. A meter ruler, protractor, spring balance. There is nothing to measure diameter, so this one is also out. Micrometer screw gauge can measure the diameter, the meter ruler can measure the length L, and the top band balance can measure the mass. So it means our answer can be B. A cylindrical tube rolling down a slope of inclination theta moves a distance L in time t. The equation relating these quantities is L into 3 plus S squared over P is equal to QT squared sine theta, where A is the internal radius. of the tube, and P and Q are constants. Which row gives the correct units of P and for Q? Which row gives the correct units for P and for Q? Okay, so of course we only add units if we only add quantities if they're in the same unit. We only add quantities if they are in the same unit. That is very important. We only add quantities if they are in the same unit. So L is distance in meters. L is distance in meters and T is time in seconds. So let's see the units the other side. On the right hand side, Q is, whose its units are not known. Of course, sine theta, that one has no units. Sine theta will have no units. So L into 3p plus s squared should be equal to q t squared sine of theta times p. So if we add, or we can even add here, this could be 3p times L plus LQ squared. This should be equal to QT squared sine theta times P. So if I add 3PL plus LQ squared, if I add these two quantities, then they should be having the same units. However, they say actually this is A, it is not Q, this is A. So it is 3p plus s squared over, sorry, plus s squared. The p in the denominator has gone the other side. So this is LS squared. So they said A is the internal radius. So A has units meters, and then L was distance, and L has units meters. So it means LS squared, I'll just say the units of L, the units of LS squared should be the same as 3PL. The units of LS squared are the same as 3PL because you can't add quantities with different units. And what are the units of LS squared? That is meters times meters squared, which is going to be meters cubed. So it means the units of 3PL are meters cubed. So 3PL have units as meters cubed. But remember, L alone has units as meters. So P has units as meters cubed divided by L, which is meters. So this gives us meters squared. So P is meters squared. This out. Then if P is meters squared, of course the units on the left hand side should be equal to this. It should be equal to the units on the right hand side. So the units on the left hand side is meters cubed because this 3PL has units meters cubed. LS squared has units meters cubed. So these should be the same units on the right hand side. So the units on the right hand side should also be meters cubed. So the units of Q, T squared times P, because sine theta has no units. These units are going to be meters cubed, but it is only for Q that we don't know. So Q times the units of T. T was mentioned to be T's time. So the units of T is S, but T squared. P is meters squared. Sine theta has no units. This should be equal to meters cubed. So it means the units of Q are going to be meters cubed divided by meters squared times S squared. So this gives us meters, and when S goes up, it becomes S power negative 2. So our answer is going to be meters per second squared. So the answer here is going to be, I think this will be B. You could have a shortcut. Me, I will use the longer way because I wanted people to view this very easily. Which pair of units contains one derived unit and 1 SI base units. Let's first identify SI base units. So this is SI, SI, SI. These are none of these is SI. Let's look at derived units now. All these ones are SI, so we need a derived unit. Kelvin is SI, seconds is SI, so the column is the only derived unit there. So one derived unit and one SI base unit. So this makes the answer to be A. Which pair of units contains one derived, which is the coulomb, and one SI base unit, which is the ampere? What is equivalent to 2000 microvolts? Micro is 10 power negative 6. So this would be 2000 times 10 power negative 6. So 2000 exponent negative 6, that is 2 times 10 power negative 3, which is 2 millivolts. So our answer is going to be B. The speed V of a liquid leaving a tube depends on the change in pressure. It depends on the change in pressure and the density rho of the liquid. The speed is given by the equation V is equal to K into change in pressure over rho power N, where K is a constant that has no units, so K has no units. What is the value of N? So here we are just, to find the power, we just use units, we equate units, we use the principle of homogeneity. So V is speed, which is going to be meters per second, so this is going to be meters per second. K has no units, I will not get bothered about it. P is pressure. We know that pressure is force over area. Force is kilogram meters per second squared divided by area, which is meters squared. So change in pressure will have units as kilogram per meter, because it is meters divided by meters squared, S power negative 2. So this will be kilogram per meter, S power negative 2, divided by density, which is kilogram per meters cubed. But this one is raised to power n. So kilogram can cancel out. So you have that m per second is equal to m power negative 1 divided by m power negative 3, then raised to power n. We subtract the powers, which becomes negative 1 minus negative 3 becomes m power 2, then s power negative 2, but this is raised to power n. Okay, so I can find n by using m. So we have m power 1 on the left hand side. On the right hand side, we have m power 2 power n becomes 2 power m power 2n. So this means n is going to be equal to 1 over 2, which is a half. So our answer is going to be A without wasting time. N is a half. You could also verify using s. If you say s power negative 1 on the left hand side, should be equal to s power negative 2 again raised to power n. Still you get a half. The maximum theoretical power P of a wind turbine is given by that equation. P is equal to K rho AV power n. Rho is density, that is kilogram per meters cubed. A is area, which is meters squared. V is speed, which is meters per second. K is a constant with no units. What is the value of n? So we equate the units. P was power. We know power can be work done over time taken. The units of work done, force, kilogram meters per second squared times distance, which is meters. So it becomes kilogram meters squared per second squared divided by seconds. So power becomes kilogram meters squared per second power negative 3. So I'm now equating the units. So I have kilogram meters squared per second cubed equaling 2. K has no units, I will not include it. Kilogram per meters cubed for density, meters squared for area, meters per second, but this is raised to power n for speed. So I want to find n. So I'll just look for either m or s. On the left hand side I have m squared. Then on the right hand side I have m power -3 times m power 2, so I add the powers, times m power n, so it will be plus n. I simply add the powers. So on the left hand side I have 2 equals to -3 plus 1, which is plus 2, which is -1. So 2 is equal to -1 plus n. That means that n is equal to 3. So our answer is going to be C, n is equal to 3. What is the unit of resistance when expressed in SI base units? I think we have expressed this unit so many times, but we can still do this. So I can say power is equal to I squared times R. So resistance will be equal to power over I squared. We know that I squared will be equal to ampere squared. Then for power, I now know power is work done over time taken, and I've seen the units as kilogram meters per second squared. This is squared for energy, divided by seconds, which became kilogram meters squared per second cubed. So the units of R are going to be kilogram meters squared per second cubed divided by ampere squared. It becomes a power -2. So this is out, this is out, this is out. So our answer is going to be B. Which quantity can be measured in electron volts? Of course, that is a unit of energy. Electron volts is a unit of energy. So the answer is precisely C. Although the unit electron volts may not be seen many times in AS, it is a unit of energy. You remember, for those who studied some A level, 1 electron volt is the same as 1.6 times 10 power -19 joules. The unit of specific heat capacity is joules per kilogram per Kelvin. What is the equivalent unit? The equivalent in terms of SI base units, we just remove the joule. The joule is a unit for energy. Energy is work done, and work done is force times distance. Force is kilogram meters per second squared times meters. So it becomes kilogram meters squared per second squared, that is for energy, then times per kilogram, then per Kelvin. So per kilogram has cancelled. So I don't expect kilogram in this unit. So I have meters squared remaining, second power -2, then per Kelvin. So this means our answer here is going to be D. What is the vertical component of this displacement vector? We resolve 5 into the vertical, so that will be 5 sine. In the vertical it will be sine 37, or I can say 5 cos, but this will be cos of 90 minus 37, which is 53. So 5 sine of 37, which is 3, or I can say 5 cos 53, which is the same. So this is 3.0. The answer is going to be A. A 0.1 kilogram mass is taken to Mars and then weighed on a spring balance and on a lever balance. The acceleration due to gravity on Mars is 38% of its value. On the Earth. What are the readings on the two balances on Mars? Of course, a 0.1 kilogram mass is taken to Mars and then weighed on a spring balance. So on Mars, we are using a spring balance and on a lever balance. So we are also using a lever balance on Mars. The acceleration due to gravity on Mars is 38% of its value on Earth. What are the readings on the two balances on Mars? Assume that on Earth, G is equal to 10 meters per second. So the spring balance is going to measure the weight, and the mass will be measured by the lever balance. So because the river balance is the one which is in kilograms. So of course the mass remains the same. That means this one is not going to be correct. We remain with B and C. The mass must be the same. So note that they said acceleration due to gravity on Mars, I'll call it G on Mars, is 38%, that is 0.38 of its value on Earth, that is times 10. So it means the weight on Mars is going to be 0.38 times 10, that is G, then times the mass, which is 0.1. In other words, weight is equal to M times G. M is 0.1, then times G, which is 0.38 times 10. I think this gives us 0.38 newtons. So our answer is going to be B. What is equivalent to the unit of electric field strength? Also, although electric field strength was removed, we know that electric field strength is the force acting on a unit positive charge. The force is kilogram meters per second squared because it is mass of acceleration, mass times acceleration. And the charge is IT, which is I is amperes, T is seconds. Force is MA, and the charge is current times time. So we now simplify this. So we have kilogram meters. When S goes up, it becomes S power negative 3. When A goes up, it becomes A power negative 1. So the answer is going to be C. When the brakes are applied on a vehicle moving at a speed V, the distance d moved by the vehicle in coming to rest is given by the expression d is equal to k v squared, where k is a constant. What is the unit of k expressed in SI base units? So when the brakes are applied on a vehicle moving at a speed v, so v is speed, which is in meters per second, d is distance, which is in meters. So we want to find the units of k. So k will be equal to d over v squared. The units will be d, which is meters, divided by meters, meters per second, but this one is squared. So this becomes meters over meters squared s power negative 2. So m divided by m squared becomes per meter. Then 1 over s power negative 2 becomes s squared. In other words, here it is like having s power 0 divided by s power negative 2. You subtract the powers. 0 minus negative 2 becomes s power 2. So our answer is going to be A. Which list contains one vector and two scalar quantities? One vector. These ones are all vectors. There is two vectors, one scalar, which is wrong. One vector, two scalars. The answer is going to be C, because momentum is a vector, mass and speed are scalars. A scalar work, density is a scalar, energy is a scalar, so this is also out. Which pair of quantities contains one vector and one scalar? Displacement is a vector, force is a vector, that is out. Kinetic energy is a scalar, power is a scalar, that is out. Acceleration is a vector, momentum is a vector, that is out. Automatically our answer is D. Velocity is a vector, distance is a scalar. The unit of resistivity expressed in terms of base units is given by kilogram x power 3, y power negative 2, z power negative 3. The unit of resistivity. Which base units are x, y, and z? So we know that resistance is equal to rho L over cross-sectional area. But resistance can also be equal to V over I. Resistance can also be V over I. V, potential difference, can be energy over charge. So the units of V, potential difference, can be energy, which is kilogram meters squared per second squared, divided by charge. Charge is current times time. This is energy over IT. So this is ampere seconds. I just wanted you to see that the units of V can be kilogram meters squared per second cubed per ampere. That is V. So resistance can be kilogram meter squared S power negative 3 divided by A power negative 2. So they say the unit of resistivity is that. So I make rho the subject. Rho is going to be equal to R times A divided by L. So let the units be R. For R, it is V over I, which is kilogram meter squared per second cubed per ampere divided by ampere. That is R. Then times A, which is area, that is meters squared. Then divide by L, where L is in meters. So we just simplify this. I'll just simplify this. So this becomes kilogram m power 2, m power 2, that is m power 4, so it becomes m power 3. S power negative 2, S power negative 3 is only alone, so it will be S power negative 3. A power negative 1 divided by 8 becomes A power negative 2. Now let's compare with the kilogram x cubed, y power negative 2, z power negative 3. So x must be m, x is meters, so this is out. Then y must be ampere, y must be ampere, y must be ampere, so the second is out. Z must be s power 3 because z is raised to power negative 3. Z must be s, so the answer is going to be B. A student carried out an experiment in which an electric current was known to decrease with time. The readings he found from first to last were 3.6, 2, 2.81, 1.13, 1.76, and 0.90 milliamperes. Which statement could not explain the anomalous 1.13 milliamperes? So here we notice that from 3.62 we move to 2.81. There is a decrease of about, what is that difference? 3.62 minus 2.81. There's a difference of 0.81. Then 2.81 minus 2.81 minus 1.13. This is 1.6. Then the other one is 1.76 milliamperes. Let me check 1.76 minus 0.9, 0.86. So which statement could not explain the anomalous 1.13 milliampere reading? He has reversed the third and fourth readings in the result. That could be possible. Perhaps he interchanged the fourth reading with the third. That could be possible. That could explain that. Number 2, he read the ammeter incorrectly. The reading should have been 2.13. That is also possible. This reading could instead be 2.13 instead of 1.13 because the values are decreasing. He took the current reading at the wrong time. This one does not make any sense, but is also very possible. He might have taken the current reading at the wrong time. There was a systematic error in the readings from the ammeter. This one cannot be explained by these values decreasing. That cannot be explained by a sudden difference in the values that were initially decreasing, because a systematic error affects every value. It does not only affect one value. So this one cannot be explained by this anomalous reading. So that one is out. The diagram shows a calibration curve of a thermistor drawn with an unusual scale. The scale is unusual on the vertical axis. What is the thermistor resistance correspond to a temperature of 40 degrees Celsius? Okay. So let's first find the difference or the range here, or the representation of one bar here. So here between 100 we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So this one is 1000 minus 100 divided by 9, which I think this gives us 100 ohms. So every line there, every horizontal line there is going to represent 100 ohms. So 40 degrees Celsius is corresponding to I think this is the fourth. 1, 2, 3. It is actually the third line, or the fourth line from 100. So this is actually going to be 100 times. So this is 100, 200, 300, 400. So this is 400. That is 400 ohms. So the answer is going to be C. That answer is automatically going to be C without even anything. There is no reasoning here. Just finding what one horizontal line is going to represent, and we saw that we got 1000 minus 100 divided by the 9 bars, or the 9 divisions. So each division is representing, or is corresponding to 100 ohms. So 40 degrees Celsius corresponds to 400 ohms. Which pair of quantities contains one vector and one scalar? One vector, one scalar. Displacement is a vector, force is a vector. This is out. Kinetic energy is a scalar, power is a scalar, that is out. Acceleration is a vector, momentum is a vector, that is out. So our answer is going to be D. Velocity is a vector, distance is a scalar. One property Q of a material is used to describe the behavior of sound waves in the material. Q is defined as the pressure P of the sound wave divided by the speed V of the wave, and the surface area A of the material through which the wave travels. That is, Q is given as P over VA. What are the SI base units of Q? So P is pressure. Pressure has units force over area. The units are going to be kilogram, meters per second squared divided by meter squared. So that is kilogram per meter per second squared. Then V is speed, that is meters per second. A is area, which is meters squared. So I'll just substitute the units of Q will be kilogram per meter per second squared divided by V, which is meters per second, times A, which is meters squared. So we simplify this. So this will remain with the kilogram in the numerator. Meters power -1 divided by meters power 3. We subtract the powers. So it becomes meters power -4. Meters power -1 divided by meters power 3. We subtract the powers. So it becomes meters power -4. S power -2 divided by S power -1. We subtract the powers. So that is -2 minus -1, which gives us S power -1. So our answer is going to be C. The diagram shows a displacement vector. What is the vertical component of this displacement vector? So we just resolve this vertically, and I think the answer is going to be A. If I'm not mistaken, no, it is not A. So this is 5, the vertical component. So it is 5 sine of 53. 5 sine 53, that is 3.993. So this is approximately 4.0. So the answer is going to be B. Or it can be 5 cos 27, which is still going to be 4.0. 27 is 90 minus 53. What is the unit of power expressed in SI base units? If you're now an expert, there are some of the units that you don't need to think much about. Power is work done over time, which is force times distance over time. Force is kilogram, meters per second squared, distance is in meters, time is in seconds. So you have kilogram, meters squared, S power -2 divided by S, it becomes S power -3. So our answer is going to be kilogram, meters squared per second cubed, so it is A. Which statement is incorrect by a factor of 100? Incorrect by a factor of 100. I think we know that atmospheric pressure is about that. That one is fine. Light takes 500 seconds to reach the Earth. It reaches us from the sun. I think that is correct. That is approximately 8 minutes. Light takes approximately 80 minutes to reach us. That is very true. It is a value that you are familiar with. The frequency of ultraviolet is 3 times 10 power 12. I think this is not true. This is not true. We can verify. How do we verify this? By looking at the wavelength. Because we must be familiar with the wavelength of ultraviolet. From Menera's mother is visiting Uncle Xavier's garden. Visible light has between, on the side of infrared, this is 700 or 7 times 10 power negative 7 in meters. On the other side of violet, it is 4 times 10 power negative 7 in meters. So the wavelength equivalent to this frequency should be close to that of violet. Let's check. So V is equal to lambda times F. So lambda is equal to V, speed of light, which is 3 times 10 power 8, divided by the frequency, which is 3 times 10 power 12. This gives you a very large wavelength. 3 exponent 8 divided by 3 exponent 12. So it is giving us a wavelength of 1 times 10 power negative 4, which is very large. So this is 1 times 10 power negative 4 meters. So that means this is not a reasonable estimate. It is actually incorrect by a factor of more than 100. It is incorrect by a factor of more than 100. Actually, the factor could be 1,000. A cyclist is traveling due south with, by the way, the lifespan of a man is about 2 times 10 power negative 9 seconds. You can convert it into years and see if it makes sense. Let's convert it into years. So this one is going to be 2 times 10 power 9 seconds into years. I will divide by 1 year is 365 days, which is 24 hours, which is 3,600. We change it to days. So 2 exponent 9 divided by 365 times 24 times 3,600. So that is 63 years. So this is approximate 63 years. That is a reasonable lifespan. A cyclist is traveling due south with velocity u. The wind is blowing from the northeast with velocity w. The wind has a velocity v relative to the cyclist, where v is w minus u. Which vector diagram shows the magnitude and direction of velocity v? So v is w. I can fix w. Then instead of adding u downwards, I'll put it upwards. So it is w minus u. So I'll put u here in the opposite direction. If I put u in that direction, then the resultant must be, if this w minus u is in this direction, then v must be in the opposite direction. The resultant must be in the other direction. So it means this one is out. We are seeing the resultant is in the horizontal. V is in the horizontal, so this is also out. This is also out. So our answer is automatically A. So this is W, this is the wind, which is W. Then this is going to be U, which is negative, reversed, so that is V. Alternatively, this is minus U, and this is W. So if we form that loop there, the resultant is the other way around. Or if we form this loop there, the resultant is still the other way around. So that is making the answer to be A. The diagram shows the stem of a Celsius thermometer marked to show initial and final temperature values. What is the temperature change expressed to an appropriate number of significant figures? So this value is each division here. We have between -10 and -5, we have 10 divisions. So that is 5 divided by 10, that is 0.5. So this is negative, each division is 0.5. So this is 0.6. So it is negative 6.5. This is negative 6.5. And here, this is 10, 11, 12, 13, 14. So this is 14. So that is 14. So we want the difference in temperature. So the difference is going to be 14 minus negative 6.5, which gives us 14 plus 6.5. That is 20.5. So that is 20.5 degrees Celsius. So the answer is going to be B. Which row shows an SI-based quantity with its correct unit? Charge is not SI-based quantity. PD is not SI-based quantity. So A and C are out. Current is in amperes. Temperature is supposed to be in Kelvin. So the answer is B, because temperature is not degrees Celsius. SI-based unit is Kelvin. A pendulum bob is held stationary by horizontal force H. The three forces acting on the bob are shown in the diagram. So these are the three forces acting on the bob. The tension in the string of the pendulum is T. The weight of the pendulum bob is W. Which statement is correct? H is equal to T cos 30. So I will draw a horizontal line here. This angle here is going to be, if this is 90, this is 60. So this angle here is also going to be 30 degrees. So when I resolve T in the vertical, it will be T sine. T in the vertical, it will be T cos of 30. If I resolve T in the vertical using 30 degrees, it will be T cos 30. If I resolve T in the horizontal using 30 degrees, it will be T sine 30 in the horizontal. So the question is, which statement is correct? Which statement is correct? H is equal to T cos 30. This is not true. H is T sine 30. T is equal to H sine 30. So this is also not true. W is equal to T cos 30. W is T cos 30. We have seen T cos 30 upwards is equal to W, so this is correct. W is T sine 30. This is wrong, so our answer is going to be C. Which estimate is realistic? Which estimate is realistic? The kinetic energy of a bus traveling on an expressway is 30,000 joules. Kinetic energy is 30,000 joules. So to check which one is realistic, of course, let's check the kinetic energy by finding the mass, if it is realistic. So mass is going to be equal to twice the kinetic energy divided by V squared. So this will be 2 times 30,000 divided by V. The speed of a bus on a highway is 80 kilometers per hour. So 80 kilometers, let's say it is 80 kilometers per hour, non-express highway. 80 kilometers per hour, which is 80,000 divided by 3,600. So 80,000 divided by 3,600. I'm changing it to meters per second. So that is 22, approximately 22. So it's 22 squared. And now I will say 60,000 divided by 22 squared. This is giving us a mass of a bus as 123 kilograms, which doesn't make any sense. The power of a domestic light is 300 watts. The power is 300 watts. I think this is also not very realistic. Normally the domestic lights that we use are 45, 25 watts to around 75 or 100 watts. At home, you must have seen the lamps. The temperature of a hot oven is 300 Kelvin. This is also not realistic because 300 Kelvin is the same as 300 minus 273. 300 minus 273, this is even lower than the body temperature. So this is 27 degrees Celsius. So this one is also out. Then it means our answer is going to be D. The volume of air in a car tire is 0.03 meters cubed. If we want to find out that this is realistic, we can estimate the radius of the tire. Remember the radius, we must get the external radius minus the internal radius, and that will give us that part which has air. But let's just come up with an estimate of the radius, the the radius over which the air is occupied. So if we assume that let this be the first internal part, let that be the external part. So if I can find a cross-sectional area times that part there, I will get the volume. So this is pi r squared times that part there. Of course, you can estimate this part here. You can estimate that thickness. Perhaps you can say it is 15 centimeters and so on and so forth. And you try to find what the radius would be. And you'll notice that actually the volume of air in a car, this is a reasonable estimate. If the others are not reasonable at all, then D is the realistic one. Two forces of equal magnitude are represented by two coplanar vectors. One is directed eastwards. One vector is directed eastwards. Okay, one is eastwards and the other is directed northwards. So the other could be northwards. What is the direction of a single force that will balance these two vectors? A single force that will balance these two vectors. So if I join them head to tail, let me join them head to tail. Let's say this is to the what? To the left. No, eastwards is to the right. One is directed eastwards, the other one is northwards. So let's say this is eastwards. Then I add the other one which is northwards. It means if these form a result, that loop, it means the resultant should be the other way around. This is the resultant. So if the resultant points, this degrees, it is pointing north of east. The resultant is pointing north of east. Then the vector that should balance these two should be pointing the other way around. It should be pointing south of west. Is it south of west or southwest? So it should be pointing southwest because the resultant is pointing northeast. Therefore, a force which will balance the one which is pointing northeast is the one which is pointing southwest. So this one here which I've drawn is the one which balances the other one in the other direction. So the answer is going to be D. This question is not asking for the resultant of the two, but it is asking for a single force which cancels out the resultant. So if the resultant is in that direction, which is northeast, then the one which cancels it out should be in the southwest, because when you draw the compass like this, northeast, then the other one should be southwest. So it means the answer is D. The spring constant K of a coiled wire spring is given by that equation. What is a suitable unit for G? R is radius, so R is in meters. N is the number of turns of a wire, so this one has no units. R is the radius of each of the turns, so this is in meters. The quantity G depends on the material from which the wire is made. What is a suitable unit for G? K is the spring constant, and remember spring constant can be got from force over extension. So this one has units in newtons per meter. That is the spring constant, newtons per meter. Okay, so what are the suitable units for G? So G is equal to K times 4 n r cubed divided by r power 4. So K is the spring constant, which is newtons per meter. 4 I will ignore, 4n is a number, I will leave it. R is radius, so this will be meters cubed. R power 4 will also be r power m power 4. So we simplify this, becomes newtons. M power negative 1, so this is m squared over m power 4 times newtons. So it becomes m power 2 divided by m power 4, which becomes m power negative 2. So this is m power negative 2. The answer is going to be A. What is a possible unit for the product VI, where V is potential difference across a resistor and I is the current through the same resistor? So we want the suitable unit. V is volts. V potential difference is energy per unit charge. Since we don't have columns, I'll remove here. Energy is work done. It can be work done per unit charge. Charge is IT. So work done is force times distance. Since we have newtons here, so this can be force times distance over I times T. So V is going to be newtons, Newton meters over amperes seconds. That is V. Then the product V times I. Remember I is seconds. So V times I will have units as Newton meter over ampere seconds times I, which is amperes. So ampere cancels out. So I remain with the newtons meter per second. So the answer is going to be D. What is a reasonable estimate of the average kinetic energy of an athlete during a 100-meter race that takes 10 seconds? An athlete, so it is a 100-meter race that takes 10 seconds. It means the speed is approximately, speed is distance over time, that is approximately 10 meters per second. So we are just checking them, we are just going to check which mass does each of these energies give. Remember, kinetic energy is a half m v squared. So m is twice kinetic energy divided by v squared. I will check only this one here because I know that is going to be the answer. So that one m is going to be 2 times 4,000 divided by 100 because it's v squared. So this is giving us 80 kilograms. That means if I was to use 40,000, I may get a mass of 800 kilograms, and no athlete is can have a mass of 800 kilograms and again continue running. When I use 40 grams, I'll get a mass of around 0.8 kilograms or 0.08 kilograms. That means that can't be a mass of an athlete. 400 could give me a mass of 80 kilograms. So the most reasonable estimate is going to be C, where the mass, it gives us a mass of 80 kilograms. A light meter measures the intensity I of the light falling on it. Theory suggests that I varies inversely as the square of the distance D. Okay, so they have told us that I is inversely proportional to the square of D, which means I is going to be a constant divided by D squared. Okay, which graph of the results supports this theory? Now, if the graphs are all I against D, so if we compare this with the y is equal to mx plus c, it means if I have a graph if I have a graph, the y-intercept should be 0 in the first place. Y-intercept is 0. From this equation here, c should be equal to 0. The y-intercept should be 0. That means a is out because the y-intercept is not 0. C is out because the y-intercept is not 0. And even then, B is out. Okay, let's first leave out B. Let's ignore A and C because the y-intercept should be 0. C should be 0. The y-intercept should be 0. This one is showing a y-intercept which is not 0, and this one. So A and C are out. That means A and C, those ones are out. Then remember the gradient. If the gradient should be positive in the first place. When you look at these two graphs, you notice that the gradient should be positive. So the gradient is positive. Gradient equals to a positive value. Because when you compare y is equal to mx plus c, you notice that m is equal to k, which is positive. So the gradient should be positive. B is showing a negative gradient, so that one is out. The gradient should be positive, so B is out because it is giving a negative gradient. Therefore, it means our answer is going to be D. I want you to note very carefully that a graph of I against D squared, if we were to sketch a graph of I against D squared, it will not be a straight line. A graph of I against D squared is similar to the one of Y is equal to 1 over X. If you're a mathematician, you must have seen a graph of Y equals 1 over X, which is actually going to be just asymptotic like this. Y is equal to 1 over X does not touch any of the axes. It is asymptotic to these axes. So a graph of I against D squared is supposed to be asymptotic like that one. It is not going to be a straight line. So that means that is automatically going to be out. So our answer is D. We started by saying 1, if I is equal to K over D squared, compare with Y is equal to MX plus C, there is no y-intercept, which ignores or which makes us to cancel out A and C. Then the gradient is equal to K, which is positive. So it means our gradient should be positive, which leaves out B. That means our answer is D. What is the unit? What is the unit watt in terms of SI base units? So the watt, of course, joule is not SI, Newton is not SI. We remain with B and C. The watt is unit of power, and power is work done over time taken. Work done is force times distance, then divided by time. So this gives us force kilogram meters per second squared because it is mass times acceleration. These meters, time is in seconds. So this gives us kilogram meters squared per second cubed. So our answer is going to be meters squared kilogram s power negative 3. So the answer is going to be C. For which quantity is the magnitude a reasonable estimate? For which quantity is the magnitude a reasonable estimate? So let's check this. Frequency of a radio wave, 500 picohertz. 500 pico is 500 times 10 power negative 12. That is a very small frequency for electromagnetic waves. So that is out because a radio wave is electromagnetic. The mass of an atom, 500 times 10 power negative 6 grams times 10 power negative 3 to change it to kilograms. The mass of an atom is times 10 power negative 27. You have seen that in atomic physics. Because if a proton is times 10 power negative 27 kilograms, so it means the mass of a proton could be above 10 power negative 27 kilograms. So that means this is too big. This one is going to be very big, so it should be almost of the order 10 power negative 27 kilograms. You have seen that in particle physics. The Young modulus of a metal is 500 kilopascals. 500 kilopascals is 500 times 10 power 3 pascals. The Young modulus of a metal is of the order 10 power 11 pascals, so that is not reasonable. The wavelength of green light is 500 nanometers. Of course, this is reasonable. This is 5 times 10 power negative 7 meters. So this is a reasonable estimate for the wavelength of green light. Remember, red is 700 nanometers. Red is 700 nanometers. And violet is 400 nanometers. So it makes sense to say green is between red and violet. So that is making sense. A vector has magnitude r and perpendicular components p and q, as shown in the figure here. Which row correctly describes perpendicular components? So we resolve r in the horizontal, it will be r cos theta. R in the vertical, it will be r sin theta. So vertical r sin theta, horizontal r cos theta, the answer is going to be D. What is the approximate temperature of a red hot ring on an electric cooker? A red hot ring on an electric cooker. So electric cookers can be they can be as hot as 500 to 900 degrees Celsius. So electric cookers can be that hot, between 500 to 900 degrees Celsius. So this means our answer is going to be most likely for a red hot ring, it is most likely going to be 800 degrees Celsius, because it can be as hot as above 500 degrees Celsius. So an electric cooker, which is already hot, can be approximately 800 degrees Celsius. But if you study A level, you can prove this using Wein's displacement law. Red hot. Red is a wavelength of 700 nanometers. You could find the corresponding temperature and you try to see if 100, 200, and 400 could be close. But you notice that the one which is closest could be 800 degrees Celsius. Two physical quantities P and Q are added. The sum of the P and Q is R as shown. Which quantity could be represented by P and Q? Okay. So kinetic energy, which quantity could be represented by P and by Q? So two physical quantities P and Q are added. So if they are added and the resultant is R, then these should be vector quantities. P and Q should be vectors. If when added head to tail, if I add P plus Q, I get R, because the R is the sum. Then P and Q should be vectors. So it means this can't be energy. We can't add we can't add the energy like that. Power, it can't be speed, so it is velocity, because if R is the resultant of this, then they have been added as vectors. Therefore, the only vector we have here is velocity, so the answer is going to be D. The density of the material of a coil of thin wire is to be found. Which set of instruments could be used to do this? So because we want the density, we need mass over volume. So we must have an instrument to measure mass, an instrument to measure mass, an instrument to measure mass. So it means in all cases, Newton meter, this will measure the weight. So it means we don't have an instrument to measure mass here in C, so C is out. We need an instrument for volume, which is going to be pi d squared over 4, then times cross section times the length L. To measure the length, we need an instrument to measure length, and we need an instrument to measure diameter. So here, protractor will not measure diameter, although the meter rule measures length. Micrometer screw gauge can measure diameter. The meter rule can measure the length L, the top band balance can measure the mass. So our answer is going to be B. A tape measure can measure L. Vernier calipers is not good to measure for a thin wire. This cannot measure D accurately or more precisely. A student is given a reel of wire of diameter less than 0.2. So this is going to be micrometer screw gauge. I think this is a repeated question, micrometer screw gauge. And is asked to find the density. Density is going to be mass over volume. Which pair of instruments would be suitable for finding the volume? Volume is going to be pi d squared over 4 times L. So to find the volume, we need diameter using a micrometer screw gauge and the length using a meter rule. So the answer is going to be B. Meter rule to measure L, micrometer to measure D. Now they made the volume bold because they know student for you to think about mass and volume. Yet they want volume alone. A 1.5 volts cell supplies 0.2 amperes to a lamp for 7 hours. So T is 7 hours. Before the lamp goes out, what is a sensible estimate for the initial chemical energy content of the cell? So energy is going to be power times time, which is going to be IV times T. So this is going to be I 0.2, then V is 1.5, then T is 7 hours, so it is 7 times 3600. So 0.2, I said energy is power times time, so 0.2 times 1.5 times 7 times 3600. So this gives us a 7560 joules. So it means this is out. This is approximately 10,000, I think. It's approximately 10,000. So this is 10,000, I think. So the answer is going to be B. Three of these quantities have the same unit. Energy. Energy is, let's check. Which quantity has a different unit? So for energy, energy is going to be kilogram meters squared per second squared divided by distance, which is meters. This gives us kilogram per meter. I mean kilogram meters, not per meter. So it is kilogram meters per second squared. That is fine. And of course, force is mass times acceleration, which is kilogram meters per second squared. They are similar. Then power is power times time. Power is work done over time, which is energy over time. So I'll get the units of energy, which is kilogram meter squared per second squared divided by seconds becomes seconds power -3. Then times time, which is seconds. So this gives me kilogram meter squared per second squared. So this one is different. Rate of change of momentum. So this is rate of change, that is change in momentum over time. Momentum is having units as kilogram meters per second because it is mass times velocity divided by time, which is seconds. So this gives me kilogram meters per second squared. So this one is the same as the other three, but this one is out. So that one, power times time, has a different unit by looking at the power of m. Decimal submultiples and multiples of units are indicated using a prefix to the unit. For example, the prefix milli represents 10 power -3. Which row gives the submultiples or multiples represented by pico? Pico is 10 power -12, giga 10 power 9. So pico 10 power -12, giga 10 power 9. So our answer is going to be C. Which definition is correct and uses only quantities rather than units? Correct. Only quantities but not units. Density is mass per cubic meter, that is a unit. Potential difference, energy per unit current, not at all. I said V is energy per unit charge. Pressure, force, point, area. So the answer is going to be C. Speed is distance per second. They said there should be no units. So it is pressure, which is force per unit area. A force of 5 newtons pushes a ball due north. Another force of 3 newtons pushes it due east. What is the magnitude of the net force acting on the ball? That one, because they are at right angles, we just use Pythagoras theorem. So the net force is going to be the square root of 5 squared plus 3 squared. 5 squared plus 3 squared, square root of the answer, which is 5.8. So this is 5.8 newtons. So the answer is going to be C. Stress has the same SI base units as, that is either pressure. Let's check here. Force over mass, not at all, because stress is force over area. So that the answer is automatically C. Force per unit cross-sectional area, that is stress. So that is force over area. To check calculations, the units are put into the following equations together with the numbers. Which equation must be incorrect? Which equation must be incorrect? To check calculations, the units are put into the following equations together with the numbers. Which equation must be incorrect? So force is 300 joules over 6 meters. Force. That means is work done over distance. I think that is correct. Force can be, because work done is force times distance, so force can be work done over distance. Because we want the equation which is incorrect. Power, 6,000 joules, that is work done over 20 seconds. I mean times 20 seconds, that is times time. Power is work done over time, so this is not correct. So this is not correct. Time is 6 meters, that is distance over speed, that one is correct. Velocity is acceleration times time. V is equal to u plus at. When u is 0, v is acceleration times time. So this one is correct. So power as work done times time, this one is not correct because power should be work done over time instead. In making a reasonable estimate of physical quantities, which statement is not correct? The frequency of sound can be of the order gigahertz. Frequency of the sound, because sound has a longer wavelength, its frequency is very low. So this one is incorrect. Because sound has a longer wavelength, that's why it can undergo diffraction. You can hear someone behind a corner. Because sound has a longer wavelength, it undergoes much diffraction around corners. So that means its frequency cannot be of the order gigahertz. It is very low. The wavelength of light, that one is fine, 600 nanometers. Young modulus is 10 power 11 pascals. Beta radiation is associated with 1 unit of negative charge. That is very true. Whenever we talk about beta, we refer to beta negative. Which statement using prefixes of the base unit meter is not correct? Which statement using prefixes of the base unit meter is not correct? Pico is 10 power negative 12, that is correct. Nano is 10 power negative 9, that is correct. Mega is 10 power 6, that is correct. Giga is 10 power 9, so this is not correct. So D is not correct. Giga is 10 power 9. 10 power 12 is tera. 10 power 12 is tera. Terabyte, megabyte, gigabyte. An Olympic athlete of mass 80 kilograms competes in a 100-meter race. What is the best estimate of his mean kinetic energy during the race? So the answer is going to be automatically B. You can estimate. Of course, if the mass is 80 kilograms, I'll just check this because I know the athlete can run at approximately 10 meters per second. So kinetic energy is equal to a half mv squared. So if I say 4 times 10 power 3 times 2 should be equal to 80 times v squared. So I find v. 2 times 4 exponent 3 divided by 80 root of the answer. So v is 10 meters per second. Let's see why this one may not be correct. So I'll just use the equation 2 times 4 exponent 2. Then I divide by 80 and I find the square root. You see the square, it means this person is almost walking, is not running. Then we can check 4. I will check 4. So 2 times 4 exponent 4 divide by 80. Then I find the square root. So that is 31 meters per second. That is a very big speed, because even a car on a highway, it runs at 22.2 meters per second. So 31 meters per second is too high. So that makes the answer to be B. Lastly, in part 5, which group of quantities contains only vectors? Speed is a scalar, so this is out. Work is a scalar, this is out. Velocity is a vector, force is a vector, displacement is a vector, so our answer is going to be C. Okay, let's stop here in part 5. Let's meet in the last part, which is part 6 of physical quantities and units. I'm sorry I may not finish all these multiple choice questions before you write your exams, but at least I've covered at least 70%. So you can also, using your teachers, you can also attempt the other topics which are remaining. We are remaining with kinematics, dynamics, and I think force, density, and pressure. These are the most important topics that are remaining that I may not be able to accomplish, but I will try to accomplish one of them. So that is the end of part 5. See you in part 6. Bye bye.